This is the luckiest maths teacher in the world. Thank you so much for tuning into this video on logarithms. So you may have wondered what these buttons on your calculator were about, the log button and the ln button. Well, you need to wonder no more. By the end of this video, you will know exactly what they're used for. So the reason we need logarithms is to help us solve a special type of equation. So you know how to solve equations like this, 2x plus 1 equals 9, that's easy. That is a linear equation. You also know how to solve quadratic equations like this. See, the thing is that these equations are a little easier because x is the thing being raised to a power. What we use logs for is to solve indical equations or exponential equations. They are equations where the thing we want to find, the x, is part of the power. So if we have something like 3 to the power of x equals 27, we sort of have two choices. Either use trial and error or use logs. So logs give us a definitive way to solve equations like this. So how would I solve this? Well, it turns out I can rearrange this equation really simply. X happens to be log 3 of 27. So that's how logs usually look. So they need a number like this, which we call the base, because that's the thing being raised to the power. And this one here you call the power. So logs need a base and a power to be put in your calculator to figure out what they are. So this is the rule for logarithms. So if a to the power of x equals b, and we're trying to solve for x, we're trying to figure out what x is, then it turns out x is equal to log base a to the power b. So logs give us a way to easily rearrange equations in which the unknown is part of the power. So that's really useful for solving those equations. As I said, we would need to use trial and error otherwise. So what actually do we do in our calculator? Now, what I have to go through is actually a bit complicated, and we normally wouldn't go through it. But I have to go through it now just in case your calculator doesn't allow you to put in the base. So what we're going to look at quickly is how to change the base of a log. So if I have something like log 3 of 27, some calculators will let you put it in like that. Some calculators won't allow you to choose the base. And that's why I'm going through the change of base formula. So that's the whole idea why I'm telling you this. So we can write log 3 of 27 in another way. So the formula you need to use is log, let's say, a of b. I want to change it to have another base. Say c is the new base. So it equals log base c power on top over log base c and the original base on the bottom. So that is the change of base formula. So how does this help me with log 3 of 27? Well, a lot of calculators, when they say log, they mean base 10. You can't change the base. It has to be base 10. ln is base e. So it's just a special type of log, okay? So I'm not going to go through exactly the importance of the number e. For now, you just need to know it's a number that's like 2.71828, blah, 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 goes on forever. So just know that it's an irrational number like pi. So that means because some calculators only allow you to put in base 10 or base e, if I want to put this on my calculator, then I need to use the change of base formula. So usually, as I said on the calculator, log means base 10. So why don't I change this so that it is base 10? So what I could do is write this as log 10 of 27. So power on top and the original base on the bottom. Okay? So log 10 of 27 divided by log 10 of 3. So the reason I write it like that is, as I said, on most calculators, it assumes that it's base 10. So you can just put log 27 over log 3 onto your calculator. The answer you get should be 3. Log base 3 of 27 is equal to 3. That is because 3 to the power of 3 equals 27. So what I originally wanted to do was find to what number do I raise 3 to get 27. The answer we see is now 3, and I've told you how to put it on your calculator. Let's look at a few more examples. So let's say I have 2 to the power of x is equal to 8,192. So again, the thing I want to find is in the power. To what power do I raise 2 to get 8192? In other words, how many times must I times 2 by itself to get 8192? Now, you could figure this out using trial and error, but it would take a while. Easier way, rearrange it. So I have x is equal to log base 2 power 8192. If your calculator does not allow you to put in the base for logs, it would just be log 8192 over log 2. And the answer you get there should be 13. Because 2 to the power of 13 equals 8192. So you could have used trial and error for that, but let me give you one that you probably couldn't use trial and error for. Let's say I just had 2 to the power of x equals 10. So this one will be an irrational number. It will not be a whole number. It will not even be a fraction with integers. It will just be a decimal that goes on forever. Because you can probably tell that 2 to the power of 3 is 8, 2 to the power of 4 is 16. So x has to be somewhere between 3 and 4. And that would be extremely hard for you to figure out without logs. So what do? I rearrange this equation. X would be log base 2 of 10. So again, your calculator might not allow you to put base 2 in, so what you would do is just put log 10 of 10 over log 10 of 2. And either way, you should get a number about 3.322. Because you have to raise 2 to the power 3.322 to get 10. 10 is not a power of 2. That's why we got an irrational number here. So that is the use of logs. That's what we have them for, so we can solve equations where the unknown is in the power, and it makes our life so much simpler. Thank you for watching this video. This has been the luckiest maths teacher in the world. Have a great day.